All right, last lesson, last homework. Tougher related rates problems. We're getting into triangles, right triangles. It's a right triangle. Right triangles, we should understand and use the Pythagorean theorem. All right, so we are told sides of the rectangle is increasing, such a way that dz dt is 1, dx dt equals 3, dy dt at the instant when x equals 4 and y equals 3. What's the value of dx dt? Okay, so it starts with your Pythagorean theorem, which is your like bringing it all together equation. If there were any fixed values, I would plug it in. There are no fixed values though. So instead, I'm just going to take the derivative of this with respect to t. And one thing I can note right away is that they all have a 2, so I can all cancel the 2. All right, so we want to find dx dt. So this is what I'm trying to find. I got x is 3, y is, sorry, x is 4, y is 3. X is 4, y is 3. Dx dt is equal to 3 times dy dt. I could probably plug that in instead of dx dt. 4 times 3 dy dt. And dz dt is 1. But I'm missing a piece of information here. I guess I want to find dx dt. I probably should have gone with 1/3 dx dt is equal to dy dt. Probably would have gone with that. So let's change this to 1/3 dx dt. See how that's going to work out nicely. Dx dt. Okay. I'm going to have to find z when x is 4, y is 3. This is not tough, and we all have to do that often. Given x squared plus y squared equals z squared, if x is 4, y is 3, z is going to have to be 5. This is a 3, 4, 5 right triangle. We're going to assume all distances are positive, so don't put a plus or minus. We're going to talk about this being a positive length, not a negative. So this turns into 4 dx dt plus another dx dt equals 5. 5 dx dt equals 5. Dx dt equals 1. Okay, good one to start off with. Airplane is flying towards a radar station at a constant height, 3 kilometers above the ground. If the diagonal distance between the airplane and the radar station is decreasing at a rate of 400 kilometers per hour, when the straight line distance is 5 kilometers, what is the horizontal speed of the plane? All right, so let's draw a picture. It's helpful to draw a picture. We got a radar station. We got an airplane. Airplane, sure. The airplane has a constant height of 3 kilometers. The diagonal distance is decreasing. I'm going to say that's dd dt. It's negative 400. That's fast. And the straight line distance, that would be d as well, is 5. What is the horizontal speed of the plane? So the horizontal speed would be dx dt, and that's what I'm trying to find. All right, well, again, our tying equation is going to be x squared plus y squared equals z squared, or d squared, really. But there's one thing that I need to pay attention to and use because it's going to help me tremendously. And that's the fact that y equals 3 is a fixed value. Since it's fixed, my new situation for this airplane and this radar station will always be this. X squared plus 9 equals d squared. Okay? I don't want to take the derivative of this. I'm going to take the derivative of this guy because we'll see that the y's aren't going to matter. I get 2x dx dt equals 2d dd dt. And d is 5. Okay, I can cross off the 2's as well. D is 5. d dt is negative 400. I'm trying to find dx dt. I'm going to have to find x. So here comes our extra step. I have to find x when y is 3 and d is 5. We kind of just dealt with this. It's another 3, 4, 5 right triangle. Just to show you though, x squared plus 3 squared equals 5 squared. X squared plus 9 equals 25. X squared equals 16. X equals 4. So 4 dx dt, I don't like that. Yeah, whatever. So 4 dx dt equals 5 times 400, negative 400. I'll divide by 4. Dx dt equals, that becomes negative 100, which is negative 500 kilometers per hour. The same moment, how quickly is the angle of elevation between the radar station and the plane changing? All right, so same situation. We got an angle. Let's see if I can do my radar. My radar. Okay. A plane. Okay. The plane is 3 miles off the ground. It's fixed. We got an angle here that's changing. We know how quickly the hypotenuse is changing. And I know the length of my hypotenuse, but I also know, you know, from the last problem, that horizontal distance at this moment. Okay, we're going to use our friend SOHCAHTOA, and we're going to pick the right trig function. We will pick a trig function based off our fixed values and our d dt, whatever I have given. So for this example, y equals 3 is fixed. I'm given d dt. That's the vertical, that's the opposite. This is the hypotenuse. I should be taking sine. Sine of my angle will equal the opposite over the hypotenuse, but the opposite will always be 3. Okay? We are ready to take the derivative of this. Don't plug in anything else. I get cos theta d theta dt, which is what I'm trying to find, equals. Now let's be careful here. You can either use the quotient rule. I prefer you write this as 3d to the negative first, and its derivative would be negative 3d to the negative second, which is negative 3 over d squared, d dt. Okay? Now this is great because I have d, 5, I have d dt, negative 400, I'm trying to find d theta dt. I'm going to need to find the cosine of theta. Well, the cosine of theta is equal to the adjacent side over the hypotenuse, or the horizontal over the hypotenuse. The adjacent side is 4, the hypotenuse is 5. So cos theta equals 4 over 5. That's easy. I don't have to worry about angles and inverse trig functions or anything. I got cos theta equals 4 over 5. Okay, I can solve for d theta dt. I got -3 times -400 times 5 over 25 times 4. So like multiplied by the 5, it comes up, divided by the 4. This goes to 100. This goes to 1/5. So it's -300 over 5. So that's -75. Well, it's a positive. That's positive 60. Sorry, 60. Okay, now this is radians per whatever, second, minute. We're only talking about radians here. So there we go. Next one. Boat is being pulled into a dock by an attached rope, which passes through a pulley on the dock, positioned 6 meters higher than the boat. So I got a pulley on a dock. Here's my pulley. Here's my rope pulling a boat. Here is my boat. Boat. There you go. Rope is being pulled in at a rate of 3 meters per second. Okay, so again, it's going to be dd dt. It's getting pulled in. I'm going to say that dd dt is negative. I probably could have said that. I did say that here. That decreasing. Okay, so we're good. We found that dx dt was negative. It's not really because I'm going to the left. It's because I'm coming towards the radio station. So negative because it's going towards the radio station. Okay, so keeping track of going towards or going to away. This negative is because it's coming towards. It looks like this height is fixed. I feel like this is the same situation. I don't know why I gave you the same situation twice, but whatever. How fast is the boat approaching the dock? This is the same thing. I'm upset at myself for I thought I gave you like as many different scenarios as possible. But it'll be fine. All right, so dx dt is what I'm trying to find. When x is 8. Now here's important point here. Forgot to mention here. This d equals 5, not fixed. Don't plug it into your formula because it's not always going to be 5. Your y is always going to be 3. So I can plug it in. It's the same that's going to happen here. This y equals 6, always going to be true. Your pulley is always going to be 6 meters off the water. But your x equals 8, not fixed. So since it's not fixed, don't adjust your equation by plugging it in because it's not always true. Okay, so I'm going to, again, put in 6. and take the derivative. Oh, I really thought I made sure this homework was going to be perfect, but it'll be all right. Okay, 2's cancel. X is 8. Trying to find dx dt. I gotta find d. When x is 8 and y is 6. Well, you find it's a 6, 8, 10 triangle. 8 squared plus 6 squared equals d squared. 64 plus 36 is 100. D is 10. dt is -3. Get -30 over 8. Which is -15/4. This is in meters per second. And we're good. How quickly is the angle of the water and the rope changing at the same moment? So it's going to be the same as the last problem with the airplane. There's my boat. Here's the angle. I should be picking based on my fixed and my d blank, d whatever given. So sine, opposite over hypotenuse, same deal. Sine of theta equals the fixed y over the non-fixed d, cos theta d theta dt, after taking the derivative, equals, rewrite this as 6d to the negative first, you get -6 over d squared, d dt. We know d was 10. Might as well find these values right away. Cos theta, so x is 8, d is 10. Cos theta equals the adjacent side over the hypotenuse, so that's going to be 4/5. So I get 4/5 d theta dt equals -6 over 100 times -3. D theta dt equals -6 times -3 times 5 over 100 times 4. This is 5. This turns into 20. This turns into 3. This turns into 2. -9, that would be a +9. 9 over 40 rads per second. Makes sense, the angle should be increasing, and we're good. All right. Let's hope this is a different situation. We got a ladder. This is different. The ladder is 10 meters long, leaning up against a vertical wall. So here's my ladder. The ladder is a diagonal distance, is d, equal to 10, and it is a fixed length. The top end of the ladder is sliding down the wall. When the top end is 6 meters from the ground, it is sliding down at 2 meters per second. So when y is 6, dy dt equals 2. How fast is the bottom moving away from the wall at that instant? So dx dt equals what? Okay, sweet. Immediately 6, 8, 10. I'm seeing that it's a right triangle. I can say I don't have to do this extra step. you need to, if you don't know what you're doing, like show that this x equals 10, but we just did a previous situation. 3, 4, 5 right triangles, 6, 8, 10 right triangles, 5, 5, 5 root 2 isosceles triangles, all things you need to be aware of. What ties us all together is our Pythagorean theorem with the fixed d. Taking the derivative of this, don't forget to take the derivative of the constant. Get 2x dx dt plus 2y dy dt equals 0. Yes, the 2's can go away. X is 8. Trying to find dx dt. Y is 6. I know dy dt. It's sliding down. This should probably be a negative because it's getting closer to kind of like the ground. You probably want to say this is a negative. And now I can solve. Subtract or add the 12 divided by 8. Dx dt equals 12 over 8, which is 3 meters per second. Okay, so I did the extra step. So I'll just say find when y is 6 and d is 10. Okay, same situation with the 10-meter long ladder. However, the angle between the ground and the ladder is decreasing by 3 rads per second. How quickly is the bottom of the ladder moving away? Oh, okay, so I'm changing it up a little bit. So, same situation with my ladder. But I'm told that this angle is changing at a specific rate. d theta dt equals -3. I'm trying to find dx dt. How quickly is the bottom of the ladder moving away from the wall of the sample? When the top is 6 meters from the ground. So when the top is 6 meters from the ground, but really more importantly with the 10-meter long ladder. This is interesting. You want to find dx dt. So this is like a little bit different situation. I want to find dx dt. And I know what d is. I'm thinking I should be using the trig function cosine. Yeah, this is perfect. Because I'd get x over d. And like x is 8, but be careful. X is 8, but it's not fixed. The only thing that is fixed is this. So x over d, but d being 10. Now when I take the derivative of this, I'm going to have everything that I'll need. I got d theta dt, which I can plug in. Now, x over 10, you can write as 1/10 x. Please do not use the quotient rule for x over 10. We had this experience in our last test with x over 3. Derivative of 1/10 x is 1/10 dx dt. So, there we go. Here's dx dt, okay. d theta dt, that's -3. All I need to do is find negative sine theta. Well, sine of theta is equal to the opposite over the hypotenuse. The opposite of theta is 6. The hypotenuse is 10. So I get -3/5 times -3 equals 1/10 dx dt. dx dt equals, this is 9 times 10 is divided by 2. That's 2, so that's 18. 18 meters per second or whatever. Yep. Okay. All right. Girl's flying a kite on a string. Sweet. Here's a girl. Flying a kite on a string. Kite is 120 feet above the ground. The wind is blowing the kite horizontally away from her at 6 feet per second. At what rate must she let out the string, if this is going to be true, when 130 feet of string has been let out? So at what rate is this changing when D is 130? All right, well, since it's flying horizontally, Y is fixed. I got my Pythagorean theorem, but Y is fixed. I'm not even going to bother squaring 120 because when I take the derivative, it's going to be 0. Get 2x dx dt equals 2d dd dt. T's cancel. All right. So I gotta find x, this moment here. So I gotta go and find this value. So I'll get x squared plus 120 squared equals 130 squared. I feel like there's like a 5, 12, 13 triangle. 13 squared minus 12 squared. Yeah, I was right. X is going to be 50. So I got 50 times dx dt equals 130. dd dt is what I'm trying to find. dd dt equals 300 over 130. So 30 over 13. This would be in feet per second. Okay, next. Softball diamond is a square 6 feet on a side. Jenny is running away from first base to second base at 15 feet per second. Linda is running from second base to third base, 12 feet per second. When Jenny is 10 feet from second base and Linda is 18 feet from third base, the distance between them increasing or decreasing at what rate? All right, so there's my softball diamond. Each of them is 60 feet. If you are not aware about like first base, second base, third base, then like don't worry, like the picture would be given for you. So we'll call this first base because that's what it is. This is second base. This is third base. So first, second, third. We call this home base. If anybody needs to talk about why it's called that, ask your local softball player. Jenny is running from first base to second base. So here's Jenny. Jenny's going to be 10 feet from second base. And she's running towards second base at a rate of 15 feet per second. Linda, running from second to third. Linda's going to be 18 feet from, sorry, Jenny is 10 feet. Linda is going to be 18 feet from third, and she is running at 12 feet per second. Is the distance between them increasing or decreasing at what rate? Well, my friends, what's going to be easier to do is not look at this diagonally, but instead take this triangle and kind of translate it so that we have like this going on. where we got Jenny equal to 10, and we can call Jenny being like the X. And then we got Linda. Linda is 18 feet from third. 60 minus 18 will give me 42. She's going to be 42 feet from second. Looks like second base is what we're going to focus on. Linda is running up at 12 feet per second. So like that's dy dt. And here dx dt was 15. There's nothing fixed here. Everything is moving. D is moving. I don't know what D is. Dx dt, dy dt, they're all moving. So I'm going to use my Pythagorean theorem, but I can't plug in anything because everything's changing. And I have to take the derivative of it and leave it as what it is. Oops. Oh, my. Okay, 2's cancel. I said X is Jenny. She's moving away at 15. You know what? False. Jenny is moving towards second base. Since she's moving towards second base, she's as a dx dt of negative 15. So she's going to the right. Jenny's gonna, no, not going to the right, but Jenny's coming this way versus Linda's going that way. Linda's 42 away, moving away at 12, so the distance is getting greater. I have to find D when like X is 10 and Y is 42. Just use the Pythagorean theorem. 10 squared plus 42 squared is 1864. Square root of that is 43.174. That's the first time we don't have a nice number. You'll be able to use your calculator for this question. And if there's any questions on your quiz that you need to use your calculator for, I'll let you. Finding dt. So I'm going to do these calculations in a calculator. 10 times negative 15 plus 42 times 12 divided by 43.174. I get 8.199. Which means it's increasing and at this rate. I want to just check some calculations. Usually the problems are set up so that you get nice values, but not in this case. 10 feet from second, 42 feet from second. Moving towards, moving away. 42 squared plus 10 squared. Square root of 1864. You know, why don't we, whatever, don't worry about it. You can use your calculator for this one. All right, next one, cones. Given a fixed proportion, a conveyor is dropping sand onto a conical pile at a rate of 100 cubic feet per minute, such a way that the height of the pile is always half the radius of the pile. How quickly is the height of the pile changing when the height is 10? Okay, so I got some conveyor dropping sand onto some sort of conical pile. Yikes. Okay. Dropping sand means that's dv dt. That's 100. Okay, see it's cubic feet per minute. Height of the pile is always half the radius. So the height is always half the radius. Okay, so the radius is bigger than the height. How quickly is the height of the pile changing when the height is 10 feet? I'm giving the formula for the volume of a cone, 1/3 pi r squared h. Well, here's the deal. This is not a fixed value, but it's a fixed proportion. Which means, yes, the volume of a cone is 1/3 pi r squared h, but you don't want to take the derivative of this. Instead, you want to take the derivative of the volume of my sand, because it'll be 1/3 pi times r squared times 1/2 r. Now, I'm going to pause here. Yes, this is a fixed proportion, but what I'm trying to find is dH dt. So dH dt is what I'm trying to find. I'm going to need to use h's. So I see this equation with the r's, and I'm realizing, you know what? I don't want r's, because if I take the derivative of that, I'm going to have dr dt. I don't want dr dt. I mean, I could find dH dt given dr dt, and that's one way to do it. But like, might as well just say like, oh, 2h equals r, and use this. So the volume of the sand will be 1/3 pi times, now be careful, 2h squared times h. This is not going to be 2h squared, it's going to be 4h squared. So the volume of my sand equals 1/3 pi 4h cubed. Take the derivative. dV dt equals, 3 comes down, goes with that 3, so I got 4 pi h squared dH dt. dV dt is 100. H is 10. dH dt is what I'm trying to find. I'll get 1/4 pi is dH dt. The hundreds cancel, divide by the 4 pi as well. All right? Oh, we got a lot of problems here. I really brought it for this one. All right. Now we have to find the fixed proportion. A conical cup is 4 centimeters across, 6 centimeters deep. 6 centimeters deep, 4 across. Water leaks out the bottom at a rate of 2 cubic centimeters per second, so that's dV dt. So that means the change in the volume of the water is -2. How fast is the water level dropping when the height of the water is 3 centimeters? So we're looking at this water level, okay, and we're trying to figure out how quickly the water level is dropping, dH dt is equal to. Well, we have a cone again, and I just told you in the last situation, the volume of the cone is 1/3 pi r squared h. So given that, you got to be finding dH dt for the water. Well, it's a little trickier than we think it is because, again, h is 3, but this is not fixed. So you can't just go 1/3 pi r squared times 3. That would be wrong. Instead, what we need is a proportion. The proportion comes from the set of similar triangles here and here. They're going to share 2 angles, so the side lengths are going to be similar. That's all you need. And the side lengths are going to be proportional. So this has a side length of 2. It's 4 centimeters across, which means the radius is 2. So the radius of the cup divided by the height of the cup will equal the radius of the water divided by the height of the water. So this is the cup, this is the water. This, my friends, this is fixed. So I said that this is not fixed, and that's true. But just for making it less nice, not fixed. Fixed. This is a fixed relationship between the radius and the height. Now let's think. I need dH dt, so I want h's. I want to replace r with h's. So I'm going to solve for r. I get 1/3 h equals r. This is fixed, not pi, h. I will take that and substitute it in to my formula for the volume of the cone so that I have the volume of my water in this cup. I get 1/3 pi times r squared times 1/3 h. What am I doing? I'm replacing r with h's. 1/3 pi times 1/3 h squared times h. And I get v equals 1/3 pi times 1/9 h squared times h, or v equals, I'm just going to leave the 1/3 because I'm going to multiply it by the 3 soon. Okay, so I took a little bit of time to get myself a formula that will be easy to work with. I'll take the derivative with respect to t of this. I get dv dt equals 1/9 pi h squared dh dt. dv dt is -2. I was told that. I said when h is 3, wrote that down. So I got 1/9 pi times 3 squared times dh dt. I will get dh dt is -2 over pi. That makes sense. I'm going down the height of the water. Cup has the shape of a cone. I literally just did this one. Whatever, let's do it again. You know what? I don't want to do this again. I'm going to do it again. Same deal. It's good practice, I guess. Height of the cup is 12. Radius of the opening is 3. Water is poured into the cup. dV dt is equal to 2. At what rate is the water level rising? So we got water in this cup. It's rising. So I'm trying to find dH dt for the water. When the depth of the water is 5 centimeters. You can't use h as a fixed value because it's not. Instead, what is fixed is the ratio of the height of the cup and the radius of the cup to the height of the water and the radius of the water. I could have put the blue line on the other side. So 3 over 12, that's the ratio of the side lengths of the cup. And then r over h is for the water. Again, I'm trying to find dH dt, so I need r's. Need r equals h's. I'm going to replace r with h's. I'll get 1/4 h is equal to r. This is fixed. Plug that in. V of my water is 1/3 pi times 1/16 h cubed. Take the derivative. dV dt equals 1/16 pi h squared dH dt. dV dt is 2. H is 5. Dh dt. 16 over, no, it's 32 over 25 pi. All right. Formulas in the similar triangles being used. So we got a classic lamppost problem. We got a person who's 2 meters tall. There's my guy. He's 2 meters tall. He's walking towards the lamppost. Here's a lamppost. The lamppost and the person look very similar, but this is a lamppost. It's got light coming out of it. Person's walking towards the lamppost at a rate of 0.5 meters per second. I'm going to say that's negative because I'm going towards this lamppost. Lamp on the post is 5 meters tall. 5 meters tall. How fast is the length of the person's shadow decreasing? So the lamp is hitting the dude. It's creating a shadow. And here is the length of the shadow. All right. And we are trying to find how fast S is changing, ds dt, when the person is 3 meters from the last post. So I'm going to call this just like an x distance. This is x equals 3, but x equals 3 is not fixed. So instead of saying x equals 3, let's just like put down x. Okay, this is very important. So I'm just going to not put down 3. Instead, I'll put down x. And what we will see is that we have two similar triangles. We have this triangle, which is similar to this triangle. And turns out our formula will be in the triangles. We will have the blue triangle, s over 2, is equal to the red triangle, x plus s over 5. I'm really sorry about using s. I'll use sh because it looks like a 5. Okay? Now, I could simplify this a little bit more. 5sh equals 2x plus 2sh. 3sh equals 2x. Okay, well, take the derivative. Watch what happens. I'm going to change this to dsh. I'll get 3 dsh over dt is equal to 2 dx dt. dx dt is negative 0.5, so this will be negative 1. Divide that by 3, and I'll get dsh dt. Negative 1/3. All right, and that makes sense. The shadow's length is decreasing, so because he's walking towards it, you know, the light's going to hit and the shadow length's going to get smaller. Cool. All right, I haven't done this problem yet. Look forward to that problem. I haven't done any of these problems before, so I'm excited for this. A tightrope is stretched 30 feet above the ground between J and the T buildings, which are 50 feet apart. Okay, so it's 50 feet apart. Tightrope walker, here's a tightrope walker, walking at a constant rate of 2 feet per second, so that's dx dt. From point A to point B, all right, so he's going away from A, is illuminated by a 70-foot point above A, as shown in the diagram. How fast is the shadow of the tightrope walker's feet moving along the ground? So here is the shadow right here. And we're going to try to find how quickly it's moving on the ground. So really interesting. I'm going to call this S, and this distance the shadow's length, you know, almost from the base of this to S. And I want to find ds dt. Okay? Well, here's what I'm seeing. I'm seeing this, let's do this in red, this triangle, and this triangle, which are similar. So I'm going to set up a proportion for those triangles. So let's do the Walker's proportion. We got a changing distance x over 70 and then for the shadow I have s over 100. And I think that's all I need. I was thinking, like, do I need this in terms of x and s? But it's like the point of the shadow, how it's moving along the ground, rather than the distance. It's like how fast is the shadow of the tightrope walker's feet. So that's like dSdt. Yeah, I think I'm good. So like 100 x equals 70s, 10x equals 7s. Take the derivative. 100 10 dx dt equals 7 ds dt. dx dt is 2. 20 over 7. Okay. All right. There you go. Challenge. Ooh, okay. Shown in the figure above, water is draining from a conical tank into a cylindrical tank with a base area. This is important. So that base area, or that pi r squared, is equal to 400 pi. Immediately going to go, and r squared is equal to 400, and r is equal to the square root of 400, which is 20, right? Yeah. All right. So just keeping that in mind, that I know from that base area that radius is 20. And it's fixed. Depth h in feet of the water in the conical tank is changing at a rate of h minus 12. Great. dH dt is h minus 12. Fantastic. Write an expression for the volume of water in the conical tank as a function of h. Okay, so here comes our formulas. We got, this is 4, that's 12. So 4 over 12 will equal the radius of the water over the height of the water. We want a function of h's. So 1/3 h equals r. This is fixed. So if I got the volume of a cone is 1/3 pi r squared h, the volume would be 1/3 pi times, plug in 1/3 h, I get 1/9 h cubed. At what rate is the volume of the water in the conical tank changing when h is 3 indicates units of measure? Okay, well, like if dH dt is h minus 12, then like I could plug in 3, but let's just see. I'm going to take the derivative of this, and I get dV dt equals 1/9 pi h squared dH dt. When h is 3, dV dt equals 1/9 times pi times 9, and then dH dt is going to be 3 minus 12, so it's negative 9. So I think we got negative 9 pi. Indicates units of measure, feet per minute. It's a volume, so it's cubic feet per minute. Let y be the depth and feet of the water in the cylindrical tank. So now we're talking about this. Now we're talking about this being y. What rate is y changing when h is 3? Okay. Well, we got the volume in my cylinder, which is pi r squared h, but it's not h, it's going to be y. Okay. All right, I got it. So if I take the derivative of this, and first of all, I know what pi r squared is. Pi r squared is 400 pi. So literally, I got this. I didn't need to know the radius. I got it right here. So this is the volume of my tank. This isn't that tough. I take the derivative with respect to t, and I get dv dt equals 400 pi dy dt. Okay, well, when h is 3, I already found the rate at which the volume is changing. From the previous problem, dv dt is negative 9 pi. So I get negative 9 pi equals 400 pi dy dt. dy dt equals, now, it was negative, it was negative because it was going away from this tank. It ends up being positive because it's being added into this tank. I'll get 9 over 400, which I'm sure can be simplified. Nope, never mind. That's good. That's going to be in feet per minute. Negative because it's going out of the cone. It's going to be positive because it's going in my tank. All right, good job if you tried all these out. Those are calculus word problems.